here we are going to be analyzing polynomial graphs, and we are going to start with some new term here, new vocabulary, which is called multiplicity. And multiplicity is the number of times a root is a factor of a function. For example, here I have an example which we are going to use. So given this factored out polynomial, we can write out the roots. So the first one is 3, and the multiplicity is the exponent you see associated with the factor. So the multiplicity is 4. So it means the root 3 occurs 4 times. Then we have a root of 5, and that one has a multiplicity of 1. And we have a root of 1 with a multiplicity of 2. So that's how to write the multiplicities. So now let's see how the multiplicity affects the graph. So this is the same function as in example 1. And what you can see here, you can see all the roots. The roots of the root 3 is this one here. And see what is happening. The graph touches 3 and does not cross. So it touches but does not cross, goes back to the same direction. And then the next root is 5. So what happens at 5? The multiplicity is 1, it crosses. And then see, the next one is root 1, and what is happening? Again, the graph touches, goes back to the same direction. So some things we can note here. See, when the degree is even, see it's just touching and just going back in the same direction. When the root is singular, like 1, which is odd, it crosses, just crosses, goes to the other side. So here is another one. The root is 3, so x is equals to 3. And you can see here, and see the graph flattens when it gets to 3. It still crosses. Why? Because the root is odd, and then but flattens at 3. So as the degrees get higher, you're going to see like degree of 5, 7, it's just going to get flattened more, but it's still going to cross. So this is a summary. This is a summary for this part. When the root is singular, the graph passes through the x-axis. And then when the real root has even multiplicity, the graph touches the x-axis but does not cross it. And with an odd multiplicity, the real higher, the graph curves as it crosses the x-axis or flattens. So here we have an example. We are told to state each 0 and its approximate multiplicity, and then we write the factors of the polynomial. So I'll start from the left. The first 0 is negative 15, and because it crosses, it has a multiplicity of 1. The next one is negative 10, and because it touches, it has an even multiplicity, so I'll just use the lowest even, so 0. And then we have another root of negative 5, and there it crosses, so the multiplicity is 1, and the other intercept is at 0, and it crosses, multiplicity is 1. The next one is at 10, and what is happening? It touches, so even, and then at 15, and what is happening? Crosses, so it's even. So now I can write my factors here starting from the left. So x plus 15, x plus 15, and the next one is x plus 10, multiplicity of 2, then x plus 5, and the multiplicity is 1. Then we have x with a multiplicity of 1. I'm just going to write the x there. And then the next one is x minus 10, multiplicity of 2, and then x minus 15, multiplicity of 1. I don't have to write the 1. So that is how the factored form of the polynomial is going to look like. Okay, so here is another example. So state each 0. So I start from the left. So this is negative 3. Multiplicity is 1 because it closes. Negative 2. Multiplicity is 1 because it closes. And then at 1, you can see it's flattening. So the multiplicity is 3. Then we can now write out the factors. So f of x is equals to x plus 3, x plus 2, and the next one is x minus 1 with a multiplicity of 3. So here we need to factor and solve the polynomial. So let's start by factoring. So 3 is common. And then I see x cubed is common. So that becomes x squared plus 6x. And then plus, it's going to be 9. Okay. So when I can check it, make sure everything is correct. Then the next thing is to, remember this is still equal to 0. I'm solving it. So this is 3x. And then when I solve what's in parentheses, two numbers which can multiply to give me 9 are 3 and 3. So x plus 3 and x plus 3 is equals to 0. So that means I can also write this one as 3x cubed, x plus 3 is equals to squared is equals to 0. Since negative plus 3 occurs twice, then I can solve it. 3x cubed is equals to 0. So that means x is equals to 0. And the next one, x plus 3 is equals to 0. So x is equals to minus 3. So I got the zeros. I need to state the multiplicities. So here, the multiplicity is equals to 3 because you can see it's to the power of 3. And here multiplicity is to the power of 2. So how is that going to help me to graph this function? Okay, sketch the polynomial. The first thing I need to check is the add behavior. I see one thing I see here is that I need to know about the leading coefficient. The leading coefficient is positive. And the degree is odd. So that's going to be helpful to me. So let me sketch where the zeros are. So one of the zeros is at negative 3, 1, 2, 3. And I know from that point, since the degree is odd and leading coefficient is positive, I know the add behavior, the graph is going to be going down. And then I know the other 0, and I know at that point the multiplicity is even, so it's not going to cross, it's going to go back in the same direction. It's going to go back in the same direction. So it's going to just touch and then go back. And then the other 0, or the other intercept is at 0. So, and the multiplicity is 3. So this one is going to be flattening a little bit. And then the graph is going up, is going to be going up because I know the add behavior. I need to get an approximation of where when x is negative, so I can get some more points here in the middle. So when x is negative 2, if I plug that into the equation, I get y is negative 24. And when x is equals to negative 1, get y is equals to negative 12. So I can plug those points. So negative 2, so about negative 24, so about that point. And negative 12, about that point. So I can sketch my graph. So that's how it's going to look like, just a sketch. So I can be able to use the knowledge of multiplicity, the knowledge of the zeros, to be able to sketch a polynomial. Okay, now let's move on. So here we are given a polynomial, and then the other thing we are told is that x plus 2, there should be x plus 2. X plus 2 is a factor. That was a typo. So how do we sketch it? So let's start by breaking it down. So this is negative 2. And here, let's write the coefficients. So this is 1, 0, because you don't have x squared. 3. Then we have 2. So this is 1. So this is going to equal negative 2. So negative 2. So here we get 4. So we get 1. 2. We get 0. So then we break this down. So this is x squared minus 2x plus 1. So equal 0. Or we don't even have to write equal 0 there. So then let's factor this. So this is going to be two numbers I can multiply to get 1. So x minus 1, x minus 1. So now I can write the factors, all the factors. So I have x plus 2. So f of x. So this is the factored form of this polynomial. And then x minus 1. And remember, this is going to be squared because so multiplicity of 2. So that is the factored form of the polynomial. Now let's sketch it. So one of the zeros is at negative 2, and the other one is at 1. And we need to know the add behavior of this polynomial. So the leading coefficient is positive. I don't know what it is, but I know it's positive because I have x positive and x positive. And I also need to know the degree. So the degree is x and x squared. So it's going to be x cubed. So the degree is going to be odd. So it's going to be starting down here. And it's going to be adding up there. And I know it's going to be touching at that point. And then the next thing I can do, I know it's going to be touching. I can get the y-intercept. And the y-intercept is going to be, what is the y-intercept? Y-intercept is going to be 2. So when I plug in 0. And I can also find another point And my other point would be when x is -1, so y is going to be 4. So when I plug it in, I get 4, -1, and that's going to be 4. So now using those points, I can connect, and that is how my sketch is going to look like. Okay, now let's look at another concept called the turning points. And the turning points correspond to the local maximum and the local minimum. See, this is the local maximum, the highest point. This is the local minimum. This is another local maximum. So local means in that neighborhood. See, this is not like the highest point overall, but in this region here, it's the maximum. So we could have more than one local maximum or minimum. So the local maximum is the y coordinate of the turning point that is higher than all the nearby points. And the local minimum is the y coordinate of the turning point that is lower than all the nearby points. Then the other thing we need to look at is the turning points. The graph of every polynomial of degree n has at most n minus 1 turning points. And so that's the maximum it can have. So if a polynomial has n distinct zeros, then it will have exactly n minus 1 turning points. Okay, and so here you're told on a graphing calculator, or you can do it on Desmos, graph the function, identify the number of turning points, the x-intercepts, and the local maximum and local minimum. So let's start by getting the turning points. The turning points are, so we have this one, and this one. So we have turning points. So turning points are 3. And look at the degree. Remember, the degree is 4. Because n is 4, the maximum number of turning points is 4 minus 1, which is 3. So for this one, we can be able to see all the turning points. So we have 3. Then we go to the x-intercepts. And the x-intercept, here you need to check this on your calculator to be able to get the exact values. That's one of them. And that point is -1.4 approximate. I'm just using my Desmos to get the value. So the next value is -0.29. And the next intercept, actually there are only 2 of them. And then what else do we need to find? Okay, the local maximum. So the local maximum, again, that you're going to get from your calculator. So this is the local maximum. So local maximum, see, these 2 are the local, those 2 are the local minimum. So here, so the local maximum is going to be, let me get it over here. The local maximum is, I'll give it, the local maximum is y is equals to, and sometimes you'll see it given as a coordinate, 1.2. And the local minimum is going to be y is equals to -3, and y is equals to 0.3. And you can see if you look at the graph, you can see the head behavior. So this reminds you that this graph has an even degree and a positive reading coefficient.